Okay, my name is John Zeman, Safety Specialist with Timber Products Manufacturing Association, and I'd just like to welcome you to today's webinar on the topics of ladder safety and heat stress. So today we're going to go over those topics. First we're going to talk about ladder safety, and then we'll go on into heat stress, and we'll go through those. If you guys have any questions after the webinar, please just send me an email. It'll be the easiest way because we do record these, so we usually save the questions to the end, or just give me a follow-up phone call. That'd be great too. Okay. Let's look at the ladders. If we want to look at ladders, there's rules, there's OSHA codes, there's Washington codes, just depends on what state you're in if you have a state program. So there's, laws that regulate ladders, and those can be found under the Walking Working Surfaces section of the OSHA book, 1910, 25 through 27, if you want to look any of them up to get specific information to make sure that you're fully in that, but we'll go through the information, so you shouldn't have to do that. Now, if you're in Washington, there's the WAC code. If you're in Oregon, there's the Oregon code. Some of that specifics depending on your state program. One of the things we want to talk about, and ladders, are very important nowadays because, number one, we can get cited for it, we can get fined for it, but number two is the injuries that come from ladders are very substantial. Here in the last few years, injuries average about between 500 and 700,000 injuries per year in the United States are attributed to ladders. That's almost 2,000 people per day, and about one person every day gets killed from working on a ladder. So it makes it a very, very serious type tool that we use, and can come with some very serious consequences. Ladder accidents occur mainly because of complacency. People have become, have been climbing ladders since they were children on the playground, and they don't consider ladders as safety equipment. They just kind of use them. Another common complaint is that several ladder-related rules are almost impossible to keep and to get work done at the same time. So it becomes expected just to break the rules, get the work done. Yeah, we're supposed to keep, tie our ladder off before you climb it, or maintain 3 points of contact. But how do you get work done with one hand? So those are some of the things that go on. One of the additional resources, there's a really nice website out there called laddersafetytraining.org. It's a free site that just is a plethora of ladder safety information for any kind of follow-up that you guys may want. Let's look at some of the causes of injuries with ladders. There's three main types, and the first one is strains and sprains from unloading or carrying or setting up ladders, because they're heavy and awkward and they're hard to move around, especially if you're by yourself. And then the second one is using the wrong type of ladder, or the wrong ladder for the type of job. And the third one is falls from height due to overreaching or improper setup. So I mean, looking at a lot of these injury reports, and I've looked at lots of them throughout the years, and the big thing with most of them, and most of the people that fall off ladders or get hurt, I was just trying to reach that last thing. You go out with, without the constraints of the ladder, you reach into the left or to the right, especially on an extension ladder, and that's usually the start of most bad ladder accidents. I was just trying to reach the very last thing of the job, or while I was up there, overreaching. And too often we stretch to reach that one last thing instead of climbing down and moving the ladder. I should have just been patient, moved the ladder, and no matter how much we train people, it's kind of human nature to try to get more done with less. So understanding this reoccurring problem, we can kind of design around it, and maybe there's a better way. Some of the theory out there, I guess, some of the new research on ladder use, ladder safety, is kind of the same theory of back injuries. Don't lift things, don't use a ladder. What can we use? What can we engineer? We talk about this over and over with safety. How can we engineer out the exposure to the hazard? and that's by not using ladders at all. I mean, if we can avoid using a ladder, please do so. Ladder should be more of a PPE, more of the inside. I mean, if you can't do the job any other way, then use a ladder. You can use your bucket trucks, your scissor lifts, all those different options out there. Build scaffolding if it's going to be a long type of job. Then you have the guardrails. You have the handrails to keep you from falling. You don't have to worry about using a ladder, because working from a ladder is one of the most dangerous things you can do, because they're not stable, and if you're working, it means you're stretching out beyond the capacity of the ladder, and it's just an accident kind of waiting to happen. So stop using ladders might be one of the best options, but are the best solutions to this. But there's jobs out there that we just the only way to do them is with a ladder, so then we need to do the best thing and use it correctly. So we're going to go through some of that here, and just like, for example, the designs of ladders. If we have to use a ladder, what kind of ladder do we want to use? A lot of that can be looked at, but just by adding some outriggers to an extension ladder, we can increase the side tip stability by over 500%. So, I mean, that's, just kind of looking into some of that is really great. Now, the OSHA standard doesn't include portable ladders, with like a tie-off requirement. Just like, we talk about fall protection, you go up 4 feet. You need to use some kind of fall protection, either handrail, guardrail, or a harness, lanyard, retractable lanyard, stuff like that. But when you're on a ladder, you don't have to, by the standard, you don't have to be tied off. So what does that tell us? Well, ladders probably originally should only been used for going from one level to another, not to be worked off of. But it's some of that gray area. Some jobs have to be done from a ladder. So that's, kind of where they just left it in the gray area. So what a lot of companies are doing, though, I mean, through the research here, is, let's look at best practice. Let's not look at OSHA. Let's look at best practice. How do we stop our people from getting hurt in general? And a lot of companies are requiring people to tie off even when they're working from a ladder. So if they slip or fall or they reach too far, you got that lanyard, a self-retracting lanyard, to catch them so they don't plummet to the ground and get severely injured. So I mean, that's what some of the best practice companies are working with, is just requiring tie-offs. You go up 4 feet, you tie off regardless if you're on a ladder, even though there's no OSHA standard that says you have to tie off. So I mean, it's best practice. They require their, finding ways to get the job done. Some places have just outlawed ladders in general, just because they are so dangerous. So, if they have a scissor lift on the site, we'll use that. Don't use a ladder. Get away from ladders. Find a safer way to do things. So, well, we're going to get into some more of the meat and potatoes of this presentation. So let's look at ladder safety. When portable ladders are used for access to an upper landing, the side rails extended should be at least 3 feet above the upper landing. And when this is not possible, the ladder is secured to a rigid support at its top, and the grab rail is available to help employees get off the ladder. So what that means is, when you put up a extension ladder, a portable ladder, you put it up against something, it needs to extend past the contact point of the upper level 3 feet. And then if you can't, then you need to tie it off so that the ladder cannot move and it's more stable for you. Now, ladders need to be kept free of oil, grease, other hazards that could cause slips. We got the rungs on the ladders. They're kind of corrugated or they're rippled so that they kind of help fight against the dirt and the grease. But that's why maintaining our ladders, doing inspections, stuff like that we'll get into, is very, very important, because you need to maintain them in a safe working manner. Ladders should not be loaded beyond the manufacturer's duty rating. We'll go into some of that. I mean, do not exceed the capacity of your ladder, because it'll break. Ladders are used only for the purpose in which they were designed. I mean, people get creative. They'll tie ladders together, zip cord them, chain them, and use them for all kinds of different ways to get a job done. But remember, ladders should only be used for their specific purpose that they were designed by the manufacturer. Now, extension ladders are placed so that the work height of the ladder is 4 times the horizontal distance from the ladder's base to the structure. So if you look at this picture here, you see you go up, say, 4 feet, it's got the base of the extension ladder has to be away from the wall 1 foot. That 4-to-1 ratio, that keeps them stable. Ladders are used on stable level surfaces, or they're secured so they cannot be displaced. You got to look at what are you putting the base of the ladder, and how are you setting that up, and how secure is that, or is it uneven? Because 1 inch at the base of displacement can change the top of the ladder by like 19 inches just on kind of average use. So a little bit of change at the bottom can change the top of the ladder quite considerably and then make it very unstable. Now, ladders used on slippery surfaces should be secured and have anti-slip footings. All ladders except step ladders have non-slip safety feet, and employees are prohibited from placing ladders on boxes, barrels, and other unstable objects. One of the things you'll run into as you're working with different heights and stuff like that is it seems like everything is always 3 feet too short. I mean, you use a ladder, oh, you're short by a couple feet. You're using a scissor lift, you're short by a couple feet. It just seems like that always happens. So build that into the design of doing the work. Make sure you have a tall enough ladder. Get that. Spend 2 minutes and go get the bigger ladder. Don't work from the top of the ladder, and don't, work off of something off the ladder. Don't, put things together like this gentleman here put 2 ladders together. I mean, the stability of that, it can be good. So now, ladders used near passageways, doorways, or driveways should be protected so that vehicles or pedestrians do not strike them. Like this gentleman here, setting up a ladder. I mean, what if someone comes through, is carrying something, is not watching, he'll hit the ladder and boom, you'll fall down, right? The area around the top and bottom of the ladder should be free of slipping and tripping hazards, so you have nice flow of traffic so that you don't make things more cumbersome and increase the risk of injury. Now, the top of non-supporting ladders should be placed so that both rails are supported equally. Ladders are not moved, shifted, or extended when they are occupied. I mean, don't walk a ladder. I mean, some people do that. I mean, they've been working on ladders their whole lives. They know how to walk a ladder. People hang in duct work, stuff like that. I've seen people, they walk ladders. They're so confident up there they can do that. But climb down, move the ladder, climb back up. Take the 2 minutes. The 2 minutes, might save a major injury. Ladders that could contact exposed energized electrical equipment have non-conductive side rails. So your fiberglass ladders. See, like the gentleman here working on the Highline wires, his ladder is fiberglass, so it doesn't conduct electrical. I would strongly recommend not having any full aluminum ladders in your facility. I mean, get the good ones, or the ones that have the fiberglass side, so you don't have to worry about this electrocution factor. So phase those out if you ever have to get ladders. Now, ladders that could contact exposed electrical equipment have non-conductive side rails. Portable aluminum ladders have legible signs reading "Caution, do not use around electrical equipment," or elevated wording. Let's just get rid of aluminum ladders. That's best practice. I mean, engineeringly control it by getting rid of it, or don't buy them anymore. The top step of a ladder should never be used as a step. That's just there for stability and to hold the ladder together. It causes too much of a risk to be up there. Cross bracing on the rear section of the ladder is not used for climbing unless the ladder is designed for that purpose. Some are double-sided, but the other side is just for stability. It's not strong enough to put your weight on, so they'll break on you. Employees are prohibited from using ladders that are missing steps, rungs, cleats, or have broken side rails or other faulty parts. So we'll get into that when we get into the inspection side of this. But I mean, look, we don't use stuff that's broken. Tag it out, get it fixed. Some ladders are very expensive, but think of the other side of it, right? A competent person inspects ladders periodically for defects and after any occurrence that could damage them. After today, basically, you all will be competent people. You've gone through some kind of ladder safety training, so you're can be very competent in this area. Defective ladders are marked as defective and tagged out. We talked about that. Do not use broken ladders. That's another high risk factor where people get hurt is, well, I'll use it real quick, right? And then it breaks on somebody and somebody gets severely injured. Now, repaired ladders must meet their original design criteria before they are returned to service. So like if some of the rivets and stuff will break out of them ladders, well, can I just replace that with a screw, or how does that work? Well, a screw or like a bolt with a nut, well, use Loctite. Make sure that most of the bolts that we have laying around are usually very strong, and probably stronger than the rivets that were already in there, but make sure you use Loctite because that nut could come off. That's why they use rivets when they build the ladders, is because the nut doesn't unscrew. And then, it'll decrease the capacity of the ladder. So, think about that. I mean, if you can repair it and you're very competent and have some engineering background, look at that. But, I'd probably recommend just getting a new ladder. If you got things falling apart, there's probably a lot bigger problems with that ladder. So now employees must face ladders while climbing and descending, square up on the ladder and stay between the side rails when you go up and down. Stay very squared up. Employees must use at least one hand to grasp the ladder when they are climbing and descending. So that's that 3 points of contact: 2 feet, one hand; 2 hands, 1 foot. When you have 3 points of contact, there's no way you can fall. Same way with, we're getting in and out of our loaders and our equipment too, 3 points of contact. Use a bucket with a rope. I mean, if you're climbing up there, take the end of the rope with you and then use the bucket and lift it up with your tools. Don't carry tools in your hands when you're going up and down ladders. That's just, you cannot keep your 3 points of contact with that. So use a bucket. A 5-gallon pail with a rope, it saves lots of lives, tell you what. Employees do not carry objects, that cause them to lose their balance and not keep the 3 points of contact. Now, employees who use ladders, receive training, so after today, you guys can go train your people on ladders. We got some PowerPoints available for you to do that with. On proper use, placement, and handling. Employees know the hazards associated with ladder use and follow procedures that minimize the hazards. That's what we're kind of going over right now. And then retraining is provided periodically to ensure that employees maintain their knowledge of proper ladder use and placement and handling. So you have to keep that very in the paramount. So especially if you use a lot of ladders, I know like in the food industry and you're picking fruit, stuff like that, there's a lot of ladder use. And then, the maintenance people using ladders to fix things throughout the facilities. Keep an eye on the ladders. So here's some inspections. When you're doing ladders, these are the things you want to look at to do a competent inspection on the ladders to make sure that they're in good, safe, and working order according to manufacturer's specifications. Here's the questions you want to ask. Are ladders in good condition? Are joints between steps and the side rails tight? All hardware and fittings securely attached? I mean, are they even there? Sometimes those rivets fall out. And movable parts operating freely without binding or undue play. Are non-slip safety feet on the ladders, there? I mean, if you look at the ladders, especially your extension ladders, I mean, those will break off over time or they get hit with something and pinched or, so you got to look at that. I mean, are the rubber feet on those, like the hinged feet on there, is the rubber still there or is it just metal? So you put metal on concrete, it doesn't provide you very much grip, so those will slide on you. Are ladder rungs and steps free of grease and oil? Look at them. How clean are they? Are employees prohibited from placing a ladder in front of doors, openings toward the ladder, except when the door is blocked, opened, locked, or guarded? So if you have to work in front of we talked about this a little earlier, but you work in front of some kind of doorway or something, put up some of that yellow caution tape, run that across there. That's why we got rolls of it, right? So, guard off the area so that somebody doesn't run through there with a forklift or, come through and, cause a big event. Are employees prohibited from placing ladders on boxes, burials, and other stable bases? Are employees instructed to face the ladder when descending or ascending? Are employees prohibited from using ladders that are broken? Are employees instructed not to use the top step? When portable rung ladders are used to gain access, do you extend it past 3 feet? Do you require users of portable rung or cleat type ladders to place the base so that slipping will not occur? And do they have the stickers on them? If you do have the full aluminum ladders, you got to make sure that stickers on them. And then are rungs of ladders uniformly spaced at 12 inches, center to center? Here's some of the duty ratings. It's very important. Depending upon what your job is. If you're just using it to move up and down from one level, that's one thing. If you're doing that plus carrying stuff, that's another thing. So if you're working from it, you got to look at, well, what do your tools weigh and all that. So you don't want to exceed the capacity of your ladder because that will cause for it to break down, especially over time. It'll wear out a lot quicker. And that sticker or on the label on your ladder is very important. That's part of the citation process. When OSHA comes in, they want to look at your ladders. If you can't legibly read the duty rating, that whatever the manufacturer set forth on there, that's a citation. So you need to look at that. If you're missing that, research what kind of ladder you have, and at the minimum, write it on there with a magic marker. I mean, it needs to be labeled, you know, at a minimum. So keep an eye on, that's one of the inspection items. You always want to look at that to see if the label's there. Okay, let's roll right on over to heat stress. Hopefully you enjoyed the ladder section. We have some checklists. We have some other things that are available to you if, for your ladders, if like this actual inspection checklist that you can go through, you know, to maintain your ladders. So for more information on that, please give me a jingle or, you know, shoot me an email, and we'll help you with your ladder program at your facility. Now, looking at heat stress, I mean, we've gone through probably one of the hottest months in quite a while that I can remember. So, I mean, a lot of you guys have been in the thick of this heat thing, you know, for quite a while. It's actually cooling off now, but let's kind of get into this. Basically, the definition or what heat stress is it's fundamentally a problem with your body giving out heat so it doesn't overheat, right? So heat stress is fundamentally a problem of dissipating internally generated heat to the environment. Now, some of the environmental factors are the amount of water vapor in the air, which is humidity. It's a major influence because the water vapor between the skin and the environment drives the evaporated cooling. How our body cools itself is driven by the amount of sweat, and the evaporation of the sweat off of our skin creates a cooling effect that displaces the body temperature heat into the environment. So the higher the humidity, the less that this can take place. So that's why when we're getting into the heat index and stuff like that, but when you look at that, that's the whole point of this. As the temperature goes up, that's one thing, it's getting hotter, we know that, but the humidity plays a very crucial role in the heat stress, because the higher the humidity, the less amount of sweat that will evaporate to drive the cooling. Now, and one of the other factors, and that's the one we can kind of affect, and that's clothing. Clothing modifies the rate of heat exchange with the greatest impact on evaporative cooling. I mean, what do we have our people wear, or what do they wear to work? A lot of that has to do with, you know, that impacts the amount of evaporative cooling that our body goes through. Now, some of the other stress is driven on our bodies through our heart rate, you know, our basic, you know, human bodies shape it's in. You know, our heart moves the blood, it disperses the heat, it pushes it outward, and the amount we sweat. Sweating can be affected a lot of times through like our body's hygiene. If we have a really dirty body, we're not going to sweat as good. It also affects the amount of heat exchange. So that's very important. And then how the core temperature, some of us run a little hotter than others, so that can have an effect as well. Now, what our body tries to do is it tries to establish thermal equilibrium. It's basically to keep our body, you know, we talk about 98.6 degrees, kind of that's the average core temperature that most humans run at. The heat stress, you know, is you kind of determine upon that, our body fighting against the environment to keep our core temperature at a stable level. So what we kind of want to look at is, you know, our external factors, and that's the heat index, and then also our internal factors, which is how our body operates, and then also the job factors, the stress we put our body under. So we kind of look at the heat stress, we kind of assess that used to predict through a prediction level that's kind of established as the average. That's where they get the heat stress kind of rate, and the chart that they put out is all established from kind of the different numbers they run on an average person. So when we look at that, some people might be more susceptible to heat stress than other people. So we kind of got to look at that. One of the biggest things, you know, with the heat index is we have to look at, well, as the heat index or as the humidity goes up and the temperature goes up, can we expect the same work out of our people? Well, from production side, we want to produce as much as possible. But when the temperature starts hitting, you know, the 100 degrees and the humidity is 80%, and we start looking at some of that stuff, we get the humidity way up there, Do we need to look at the safety of our workers and maybe push them a little bit less, maybe give them more frequent breaks, and we'll kind of get into some more of that. So looking at kind of the research that's been done here in the last couple of years, one of the biggest impacts we can have is the use of smart clothing. A lot of us are switching, so our people wear high visibility clothing, so we can kind of look into that. In the summer months, they make really nice high vis t-shirts and stuff like that that have pretty high-tech material. The textiles that they're built with can be very beneficial to this heat exchange, and it can also, brighten up their visibility as well. So we want to look at, can we engineer away the problem? We always want to look at engineering controls. Can we, increase our body's transfer of heat, and some of that can be done with clothing. And then we can look at some personal protective equipment. I know when I used to work with the highway departments, we had these deals that they could put on their heads and necks that have the gel and different things like that to kind of help with some of that. But the clothing is some of the newest research out there, is how much the clothing really can impact the heat transfer. So let's get into our presentation here. So what are some of the hot work environments? Working outside, working inside. Most of our sawmills are air conditioned, right? We close them up and we hook up the big air conditioners, and everybody stays cool all summer, right? So, right, that's not the case. So we have to look at that. Our buildings, air movement. Air movement is really good because it can move the hot air out, and when air is moving, it increases the rate of the evaporative cooling our body does. So what are some of the risk factors? Well, age, weight, physical fitness, we all transfer heat differently depending upon how our body operates. That's our metabolism. And then if we're on any medications, and then how much other substances. Alcohol dehydrates us, and we got to look at that. Water consumption and caffeine consumption. That, caffeine helps us get rid of water, actually. So lots of caffeine is not necessarily a good thing unless you equate that out with a lot of water. And water needs to be given, through a little bit constantly, not, every 2 hours kind of thing. So, and then medical conditions, and how used to are you working in heat? Is your body used to working with heat or working in a hot environment? Some environmental factors, you got the air temperature and the humidity, heat given off by our machinery, and then kind of what clothing. Are we wearing heavy coveralls? Are we wearing long sleeves, short sleeves, different things like that. And fatigue. Blood circulates to the upper layers of the skin, less blood for internal organs, performance declines, and coordination alertness decline. So as you get more tired throughout your day, your body doesn't work as good at dissipating that heat. Now, this fatigue can be taken care of through rest. That's why, between ergonomics, all these different things, getting a good night's rest is so important. Getting that TV out of the bedroom so you can get to bed at a decent time, so you can get a good night's rest. That impacts so much of the safety stuff. And then while we're at work, taking heat relief breaks, getting out of that sun, getting into a cool break room. And a lot of places are installing air conditioners in the break rooms, which is nice. Just get the people out of that environment for a little bit, let their core temperature cool back down. That can greatly, help the situation. Now, heat rash, this kind of goes back to, the skin, where the sweat isn't working right, and the sweat ducts become plugged. So taking a good shower, keeping our bodies clean, really has an impact on this evaporative cooling, so that our pores in our body and our skin, they release sweat at a good rate, and so our bodies stay healthy as far as exchanging the heat. If you do end up with some type of heat rash, go rest in a cool area, keep your skin clean and dry, and seek, medical attention, if you get any type of infection, or, if it gets to that next kind of level of problem. Now, fainting, blood accumulates in the lower part of the body, and then the brain doesn't get enough blood supply. So that really can reduce, the transfer of oxygen, and you can faint on that. So it's a sudden loss of consciousness. So that means you've pushed it way too far. And fainting, if you faint on the job, that's a recordable injury. So just so you know that. Responses to fainting, get people rest and get them in a cool, shaded area, and get them out of that heat. And it's good to maybe lay them down, help that circulate the blood. Moving around really helps increase that. Just keep the blood flow so you can get that oxygen and the blood flow back to the brain. Muscle cramps, they occur when tired muscles, sweats too profusely, and some of that, your muscles just cramp up because your body's not transferring out the impurities and the waste, and bringing in fresh oxygen and good blood supply. So a lot of that occurs because of dehydration. So drink water. Muscle cramps, painful contractions in the muscles, are uncomfortable, temporarily disabling. Low salt level can cause spasms, and too much salt can cause cramps. So you don't want to overdo the salt. I know they kind of went away with that back I remember going with my dad to work in the old days, and they had salt tablets everywhere. So so they're saying that's, you don't want too much salt. So like the Gatorade, stuff like that, they have kind of a minimal, medium level of salt. So that can sometimes help more than just plain water. So response to how do you kind of treat muscle cramps, get people rested in cool, shaded areas, drink 5 to 7 ounces of fluids every 15 to 20 minutes, kind of reintroduce the water into their system so they can absorb it back in. Avoid caffeinated beverages and alcohol. Those will just make things worse. So, stick to water, maybe Gatorade. Drink salted or carbonated replacement liquids for recovery. Gradually adjust back to the heat. Now, heat exhaustion, that's when you get super dehydrated. Large amounts of fluid are lost by sweating, so your body can't recuperate, and some of the symptoms of that are you get physically weak, fatigued, or maybe even faint. You get giddy, irritable, mentally confused. Your body's dried out. You get nauseous, and you get headache, dizziness, lightheadedness. I mean, that's all factors of heat exhaustion. So as you lose, that's why you need to constantly be kind of replenishing your body throughout the day, which is hard. I mean, we have work, people are working, and the breaks and stuff like that. So sometimes when it's super, super hot, you might want to move the breaks to, have more breaks throughout the day, only maybe every hour, hour and a half, do a 10-minute break, just so they can get out of the heat, get a drink of water, or make sure they have fluids, at their workstations. I know what I used to do is I used to take a cooler around full of, we used to mix up Gatorade in a big cooler with ice, and we go around on the hot days, and gives us a chance to kind of meet and greet our people, and also, share some Gatorade with them, especially them super hot days when that heat index is off the charts. We want to make sure our people don't go down, and we keep production up, but also keep them in a safe working kind of environment through that. Now, heat exhaustion, a person continues to sweat, the skin gets very clammy and moist, body temperature remains normal, and a person may vomit or lose consciousness, if it gets too severe. Now, what we try to do to our people is we want to get them rested in a cool area, get them watered down good, and seek medical attention, especially if it's very severe, people become non-responsive. Heat stroke is a very life-threatening condition. Body's temperature regulation system kind of fails. Your body just gives up on the whole keeping equilibrium, and you go into shock, and your body, well, you'll basically faint and pass out. So we want to make sure we don't get to that point. That's what's so important to maintain our people. I mean, we can't control what our people do when they go home. If they drink a 6-pack of beer every night and they come into work, I mean, you got to monitor that kind of stuff, especially when it's hot like that. That's why those morning meetings you have with your crew is very important. You can kind of see it's going to be 100 degrees today and it's going to be hot and humid. Look at people, make sure that they're all right. See, if they're sweating and they smell like alcohol, well, they better cut back, or have a talk with them. So that'll lead to severe heat stroke and exhaustion, especially the alcohol use. So keep an eye on your people. So heat stroke and some of the symptoms of that are kind of skin is very hot and dry. Skin appears to be red in color. You start running a temperature, your actual body temperature, because your equilibrium, your body kind of is losing the battle, gets over 103. And usually people get delirious. They won't think right. And you can kind of tell on their behavior, and loss of consciousness. Way we take care of heat stroke is get immediate medical attention. This is serious business, so you don't want to just wait around with them. So want to remove them to a cool shaded area. So help them with that evaporated cooling. Get them a cold compress. Kind of get them a cold washcloth or a towel. Get them in a fanned area, and monitor them. Keep them conscious. So what can you do? Well, report symptoms and signs immediately. So if you experience any of this, get out of that heat. Don't try to tough it out, because you need to get water if you're starting to feel dizzy or anything like that while you're working. Know your procedures that your company provides, and safety managers and safety people, we kind of have the responsibility. We need to monitor the temperature, especially in the summertime. If it's going to be super hot, we need to know that, and we need to go out there and we need to help treat our people. If we want to keep production going, we need to make sure our people have good water or Gatorade. I mean, a few Gatorades isn't going to, it's very helpful, especially those super, super hot days. So that kind of leads us into this heat index system. I mean, what does this all mean? Okay, well, as the temperature rises and the humidity rise, well, what's kind of the safe work environment? And where does the risk of this heat exhaustion start really, really going up? So if you look at the chart, you look at 100, so it's 100 degrees, and when does the humidity kind of start hitting very unsafe kind of areas? Well, you look at that, okay? If the humidity is at 60% humidity and it's 100 degrees outside, it's just like it's 132 degrees. So that's when you need to start thinking about adding brakes. I mean, this is kind of what we used to do when I used to be in the aluminum industry. I mean, we get 120 degrees in our building. It was a metal building. Get 120 degrees in there, plus our big heavy equipment that we extruded aluminum with. That added to all that, and the humidity. So you kind of start looking at that. When it hits this red number on this chart, that's when you need to start thinking about, do we need to increase brakes, add a brake, or even shut down? I mean, some of this gets severe where, people are going to drop, so, and we don't ever want to get to that point. So just kind of look at this chart. You got 100 degrees at 60%. You kind of say 90 degrees. When does 90 degrees get dangerous? Well, it doesn't get super dangerous. I mean, it can if they're not drinking water, but where you really got to start looking at heat exhaustion when it hits 95. See, 95 at 75% humidity it starts hitting that danger zone. So that's what we kind of got to be aware of. When it starts hitting 90 degrees, we need to start looking at this and start kind of looking, okay, what's the humidity then? And then kind of start factoring into that, because that's what that red number means, is that's when that danger zone, and that's when people start dropping. So be very cognizant of that as you run your facility. Now, as when you hit that danger zone, you also have to look into this other factor, and that is the duty. I mean, what are people doing? Is it light handwork, heavy work with one arm, two arms, with the whole body? How much work are they doing? How much stress are they putting their body under? And that will also push you more into that danger zone, so to say. So, I mean, if people are just, standing around, that's one thing. But if people are actually lifting heavy 20-pound 2x4s or 2x6s and all that kind of stuff, then you got to start thinking about that. Okay, that danger zone is going to hit sooner because their activity level goes up. So if their activity level is very, very high, and then the temperature goes up and the humidity goes up, you start putting together a perfect storm for a severe heat illness, so be very mindful of that, kind of maybe identify what work positions are in that heavy workload. And when that temperature starts hitting that, 90 degrees, you need to start looking at those positions, and maybe we could run different wood. Maybe we should make smaller stuff during the super hot period, if that's possible. So start, looking at that 90 degrees, start looking at the heavy workload positions and see, well, what can we do? Give them more breaks, or, give them some Gatorade, give them a water cooler with ice and Gatorade or something like that. You can get those mixes where you can mix it all up, so it's not too difficult. So, what are some engineering controls? Shade, ventilation, air cooling, air circulation, shielding from the, hot machinery, insulating radiant heat sources, use of power assisted tools. So you're not using your hands and your body so much. Maybe you can use a machine to do the heavy lifting per se, right? So we kind of got to look at this, how can we, control the hazard? And getting the personal protective equipment, and you can go out there and look on the internet. I mean, they got all kinds of stuff nowadays. Ice vests. See, like there's a picture of this ice vest where you freeze the deal, and it's like gel packs you put in the vest. I mean, especially for those guys that are doing, or girls doing those heavy and very highly active jobs when it hits 90 degrees, or that high mark. Water cooled garments, air supply systems, wet clothing, headbands, bandanas. I mean, even misting systems. I mean, some of the areas where the water's not a big deal, I mean, you can maybe put in a misting system for your people to be around. That'll help your body keep up with that evaporated cooling, so you can keep the core temperature constant. So, I mean, how do we control this heat? Well, we can't control Mother Nature, so we have to take it. What can we control though? So, use more rest periods. Nobody smokes anymore, so you don't really need a 15-minute break, maybe 2 10s, something like that. So use relief workers, switch people around. If there's one really hot kind of area in the sun even, can we put up some shade, or should we move that person more so that you can kind of share some of this? Now we want to look at the pace of work. Maybe you don't expect as much out of them when it's 100 degrees, so they don't push themselves so hard. I mean, just a lot of the managing techniques, to kind of reduce those physical demands. Shade areas, try to, stop people from working out in the sun. Can we build a shade for them? Schedule work at cooler times of the day. If you only run one shift, maybe start at 4 in the morning instead of 9 or 8 or whatever. So kind of look at that. Move people around to more of a night shift situation. To fight those, especially those dog days of summer, right? So wear light, loose-fitting clothing, and we talked about how important clothing needs to be. Breathable. It has to allow that evaporative cooling exchange. So this is one of the last things we'll talk about. I built this. I brought this over from the old days. This was huge research was done in Dubai, over in the desert. They have a lot of money over there, and they build all kinds of crazy things, I could say, ski lifts in the desert, stuff like that. So I mean, they have all these huge building projects over there, and it's 130 degrees in the shade over there. So what was happening? Well, people were dying. Lots and lots of people were dying. They're running out of workers over there. So they took a bunch of their oil money or whatever money they got, and they threw it at research. So they looked at, okay, how do we stop killing our people from heat exhaustion? Well, they spent $200 million, and the number one research, or showed the biggest change that came out of this, was a color chart. And what they did, and what the research told them, is to give people immediate response to their when they go to the bathroom, I guess. It's kind of gross, but I apologize for any of you. But this is real deal science, though. What they did is they posted this urine color chart in the bathrooms, so when people were going, they could analyze, well, where am I at on this chart? Is it clear? Is it yellow, or is it getting darker? And so that gives you direct feedback on your hydration level. So if it's clear, you're good. As it gets more yellow, you need to drink more water. So it effectively will push people to, I need to drink more water. And it showed the results of this big research deal they spent all this money on in the desert. 50% reduction in heat stress related injuries. They attributed directly to this urine color chart was hanging in the porta potties and all the bathrooms. So that's one thing to think about. I mean, it's kind of gross, but it's very, very effective, or I wouldn't share it with you. So I have these actually made up TPM urine color charts that kind of give some descriptions on all that. I think we put it out on our website, and if you would like one, just let us know, and we can certainly get that out to you. So that's the kind of the importance of this urine color chart. So that's about all we had for you today. Kind of went over the ladder safety. Make sure you use the right ladder for the job. Make sure you inspect the ladders so you can make sure that they're in working order according to the manufacturer specifications. And then heat stress. Make sure our people are getting plenty of water throughout the day. Put out some of those water coolers. That's one good way we can establish good faith with our workers too. They like to get some nice ice cold Gatorade and stuff like that, and it gives us a chance to visit with them about any safety concerns they may have. Share that with them, and kind of keep an eye on our people, especially when the temperature hits 85, 90 degrees. We need to be very mindful and do safety checks with our people. Go around, catch those heat illnesses before they cause somebody to go down. So anyways, with that, I'll bid you farewell for this month's webinar. I really appreciate you guys for attending, and please contact me, shoot me an email, whatever, give me a jingle, and we can go over any of your safety concerns and help you along the way. Once again, I'm John Zeman with Timber Products Manufacturing Association. Thank you, and have a great and pleasant day.